Welcome to another deep dive into the world of AI. This time, we are going to be exploring some pretty cutting-edge research into long context LLMs.
Long context, large language models.
Yeah, those.
That's right.
And it could change how we think about AI and information in general.
It really could.
Our guide for this journey
Yeah.
is this fascinating paper called SCBench, a KV cache-centric analysis of long context methods.
Catchy title.
Yeah, I know, right?
But very descriptive.
Don't let that title scare you away, though.
No.
We're going to break it all down for you and make it clear what it all means.
Absolutely.
So,
So these long context LLMs are really pushing the boundaries
yeah.
of what AI can do.
What can they do?
Imagine an AI that can grasp an entire code repository or answer questions about a whole textbook
Whoa.
instead of just a few paragraphs.
That's a lot of information.
It is a lot of information.
That's pretty mind-blowing.
It
It's
is.
like giving these LLMs superpowers or something.
Yeah.
But with great power comes great responsibility. There's got to be a catch, right?
Well, there is a trade-off.
Oh.
These long context LLMs are very computationally expensive.
So they need a lot of power.
A lot of processing power and memory to run.
Is that one of the big things that researchers are trying to overcome?
Yeah, that's one of the biggest hurdles right
So
now.
it's like we've built these incredible machines,
Yeah,
but we don't know how to
fuel them.
fuel them efficiently.
Yeah,
And that's where this whole KV cache thing comes in, right?
exactly.
What is that?
Think of it as the LLM's short-term memory.
Okay.
It's where the LLM stores the important information
From all the text.
from all the text that it's processing so it can access it quickly.
Okay, that makes sense.
Yeah.
So this paper goes even deeper though, right?
It does.
It breaks down the whole life cycle of the KV cache into 4 stages.
Yeah, that's right.
Okay.
It's not just about storing information.
Right.
It's about how that information is generated,
Okay.
compressed, retrieved, and loaded back into the LM's working memory.
Each stage is important.
Each stage is critical
Okay.
in how efficiently the LLM operates.
So let's try to wrap our heads around these 4 stages.
Okay.
Generation seems pretty straightforward.
Yeah.
That's where the LLM is reading the text and figuring out what needs to be stored in the cache.
Exactly.
Right.
It's like when you're reading a book and you're highlighting the key points.
Okay. Yeah.
You're deciding what's important enough to remember.
Got it.
Yeah.
But why compression?
Okay.
If we have all this extra memory,
Right.
why do we need to make things smaller?
Well,
It just seems like another layer of complexity.
it might seem counterintuitive,
Okay.
but compression is all about efficiency.
Okay.
Imagine trying to remember every single detail from a long meeting or a dense textbook.
Yeah. That would be too much.
It'd be overwhelming.
Yeah.
So we naturally condense our notes, focusing on the most important points.
Right.
And that's essentially what the LLM is doing
During compression.
during the compression stage.
So it's finding the signal in the noise?
Exactly.
But how does the LLM actually decide what's important enough to keep...
Yeah, that's where things get interesting.
Okay.
That's a big part of what this research paper explores.
Okay.
There are different methods for compressing information in the KV cache,
Okay.
and they all come with these trade-offs.
So we've got the LLM generating information,
Right.
compressing it to save space.
Mm.
What happens next?
And then
How does it actually use the information when it needs it?
that's where retrieval and loading come in.
Oh,
Retrieval is about finding the right piece of information in the KV cache,
okay.
kind of like searching for a specific file on your computer.
I can see that.
Yeah, and loading is about getting that information from the cache back into the LLM's working memory, so it could be used to answer questions or generate text.
So it's a whole cycle.
It is a cycle.
Generate, compress, retrieve, load,
And then repeat.
and then repeat.
Yeah.
What makes this research so special?
Okay.
It just sounds like a lot of technical details about how LLMs work internally.
Yeah.
Why should I care about all this?
Here's the thing. Most research on the KV cache has focused on individual tasks,
Okay.
like answering a single question or generating a short piece of text.
Right.
But this paper takes a broader view.
Okay.
It looks at what happens when the KV cache is reused across multiple tasks,
Interesting.
which is much closer to how we actually use LLMs in the real world.
That's a great point.
Yeah,
It's like the difference between sprinting and running a marathon.
exactly.
You need a different strategy if you're going to go the distance.
Absolutely.
So that's where this new benchmark called SCBench comes in.
It does.
It's designed to evaluate how well LLMs handle shared context
All right.
and multi-round interactions.
Oh, that's right.
So it's putting these LLMs through a series of obstacle courses
You could say that.
to see how they perform under pressure.
Yeah.
What kinds of obstacles are we talking about here?
Well, SCBench introduces two main types of shared context. Multi-turn, which is like a back and forth conversation,
Mm-hmm.
and multi-request, which is more like multiple people accessing the same information, like a shared code base.
So it's not just about how much the LLM can remember.
Right.
It's about how well it can manage that information over time and across different interactions.
Exactly.
That makes a lot of sense.
Yeah.
And then they tested all this on like Llama and Quinn.
Yeah, and what's even more intriguing is they tested a wide range of long context methods on some of the most popular open source LLMs.
Wait, so they're not just testing the LLMs themselves.
Right.
They're testing different ways to make them more efficient.
Yeah, exactly.
Kind of methods.
There are a bunch of different approaches.
Okay.
And we'll dive into those a little later.
Okay.
But the high-level goal is to find ways to make these long context LLMs more practical
Okay.
without sacrificing accuracy.
So it's all about finding that sweet spot.
Yeah.
That perfect balance between power and efficiency.
That's it.
I'm starting to see why this research is so important.
Yeah. But before we get into like the nitty-gritty of the different methods,
Okay.
I need a mental break.
Take a breath.
Like trying to fit a whole library into your brain.
That's a lot.
How do these LLMs even begin to process all that information without exploding?
That's a great question.
Yeah.
And it leads us to some of the most surprising findings from this research.
Oh.
They discovered some unexpected limitations with certain approaches to efficiency,
Okay.
particularly when dealing with these multi-round scenarios.
This is where it gets interesting.
It does.
Tell me more.
All right, we'll talk about it after the break.
Okay, sounds good.
Sounds good. Welcome back.
All right, so you were saying before about those unexpected limitations?
Yeah, remember how we were talking about
Yeah.
all the different methods for making long context LLMs more efficient?
Yeah.
Well, the SCBench research
Mm-hmm.
really put those methods to the test.
Okay.
And the results were pretty eye-opening.
Yeah, you mentioned some unexpected limitations.
I did.
What did they find? Well, one of the big surprises was that
Okay.
methods that focus on using less memory,
Less memory.
which sounds great in theory,
Yeah, less is more, right? Why
Right.
not just use less memory?
often don't work so well when the LLM has to handle a conversation or a series of related tasks.
Wait,
Okay.
if compressing the information is bad in some cases,
Right.
then what's the point of the KV cache at all?
That's a great question.
Yeah.
It really highlights the challenge that researchers are facing.
Okay.
It's not as simple as just saying less memory is always better.
Right.
The ideal scenario is to find the sweet spot.
The sweet spot.
Enough memory to handle the task,
Okay.
but not so much that the LLM becomes a resource hog.
So it's about finding the right balance.
Exactly.
How do you even know
Right.
how much memory is the right amount?
Oh, that's a great.
It seems like it would depend on the specific task.
You're exactly right.
Yeah.
There's no one-size-fits-all approach to LLM efficiency.
Right.
The best method really depends on what you're trying to do with the LLM.
Can you give us some like concrete examples
Sure.
of that?
Like, when would compressing the information actually be a good thing?
Hmm.
Okay, think about a classic search task,
Okay.
like finding a specific phrase
Okay.
in a giant document.
Right.
In that case, you don't need to remember every single word of the document.
You just need to remember like the keywords.
Right, you can compress it down to the essential keywords and phrases,
Right.
and you'll still be able to find what you're looking for.
So it's like using a really good index.
Precisely.
You can skip over all the irrelevant stuff
Exactly.
and jump straight to the relevant information.
Right.
Okay.
And some other tasks, like summarizing a long article,
Uh-huh.
might also benefit from compression.
Okay.
The LLM can focus on extracting the main points without getting bogged down in all the details.
Okay, so that makes sense.
Yeah.
But then you have tasks that are much more complex.
Right.
Where the relationships between different pieces of information are crucial.
Remember those multi-turn scenarios we talked about?
Yeah.
Where the LLM is having a conversation
Mm-hmm.
or answering a series of related questions?
Right.
Those are the situations where simply compressing the KV cache can actually backfire,
Why is that?
because you might lose those important connections,
Oh, okay.
those subtle nuances that help the LLM understand the bigger picture.
Oh, so it needs to keep all that in mind.
Exactly.
Okay.
And the SCBench research really highlighted this.
Okay.
They found that methods that tried to compress the KV cache too aggressively actually performed worse on tasks that required a lot of contextual understanding.
So that's fascinating.
It is.
It really challenges the assumption that less is more. when it comes to LLM efficiency.
It does.
So if simply compressing the information isn't always the best solution,
Right.
what are some other approaches?
Right. What are some other approaches? How can we make these long context LLMs more efficient without sacrificing their ability to handle complex tasks?
Yeah, that's the million-dollar question.
It is.
And I'm guessing that the SCBench research explored some alternative approaches.
They tested a range of methods,
Like what?
and one of the most promising approaches is called sparse attention.
Sparse attention.
Yeah.
I have no idea what that means.
Okay, so imagine you're reading a long document,
Okay.
and you're trying to focus on the most important parts.
Uh-huh.
You might highlight certain sentences or paragraphs,
Right.
or you might skim over sections that seem less relevant.
Yeah.
That's kind of what sparse attention is doing.
So instead of trying to remember everything,
Right.
the LLM is selectively paying attention to the parts that are most likely to be relevant.
Exactly. It's a more nuanced approach than just blindly compressing everything.
Right.
And the SCBench research showed that sparse attention can be really effective,
Well,
especially in those multi-turn scenarios,
yeah.
where the LLM needs to maintain a lot of context.
So is everything compressible to some degree?
That's a really insightful question.
Yeah.
It gets to the heart of the challenge.
Yeah.
There's a spectrum here,
Okay.
and the ideal approach likely depends on a combination of factors,
Okay.
including the specific task, the size of the KV cache, and the computational resources available.
So it's not as simple as just saying compression is bad
Exactly.
or sparse attention is good.
It's about finding the right tool for the job.
But how do we even know which tool is the right one?
Wow.
How do we evaluate these different methods?
Right. How do we evaluate these different methods and make informed decisions about which ones to use?
Right.
That's where benchmarks like SCBench come in.
Uh-huh.
They provide a standardized way to compare different approaches
Okay.
and see how they perform under different conditions.
So it's like having a set of standardized tests for LLMs?
You could say that.
But what are we actually testing here?
Right. What are we actually testing?
What are the key metrics?
Well, we're looking at things like accuracy, of course.
Okay.
How well does the LLM perform the task?
Right.
But we're also looking at efficiency.
Yeah.
How much memory and processing power does it use?
Okay.
And we're looking at things like robustness.
Robustness.
Yeah, how well does it handle unexpected inputs or changes in the context?
So it's not just about finding the fastest LLM
Right.
or the one that uses the least memory.
It's about finding the LLM that's the best all-around performer,
Right.
the one that can handle the real-world complexities of language and information.
Yeah.
Exactly.
Okay, I see.
And that's what makes this research so exciting.
Yeah.
It's not just about pushing the boundaries of what LLMs can do.
Right.
It's about making those capabilities accessible and practical for everyone.
This whole idea of sparse attention is fascinating.
It is.
It's like the LLM is learning to read strategically, just like we do.
Exactly.
But what about the situations where we don't know what the LLM is going to be asked? What if the questions are unpredictable or constantly changing?
That's a crucial point.
Yeah.
And it leads us to another fascinating concept explored in this research.
Yeah.
Query awareness.
Query awareness.
Yeah.
Is the LLM going to start asking me questions?
Not quite.
Okay.
Query awareness means that the LLM is able to take into account the user's question or request
Okay.
when deciding what information to prioritize in the KV cache.
So it's like the LLM is reading my mind.
It's not mind reading exactly.
Okay.
It's more like having a really good research assistant
Okay.
who can anticipate your needs.
I see.
For example, if you tell your assistant you're working on a project about the history of space exploration,
Uh-huh.
they might pull up all the relevant books and articles on that topic beforehand.
So query awareness is about making the LLM more proactive.
Exactly.
Okay.
More efficient at retrieving the information that's most likely to be needed.
But what if we don't know the query in advance? What if the user is just exploring a topic and the questions are emerging organically?
That's a great question, and it highlights one of the limitations of current query-aware methods.
Okay.
They tend to work best when the query is known up front,
Right.
but researchers are exploring ways to make these methods more adaptable,
Okay.
more able to handle situations where the query is evolving or unpredictable.
So it's like we're trying to teach the LLM to be a good improviser, to
Exactly.
be able to think on its feet and
Mhm.
adapt to new information as it comes in.
That's one of the most exciting frontiers in long-context LLM research.
We've covered a lot of ground today,
We have.
from the 4 stages of the KV cache life cycle
Yeah.
to these fascinating concepts of sparse attention and query awareness.
Uh-huh.
I feel like I'm starting to see the bigger picture here.
Sure.
the potential of these long context LLMs
Right.
to revolutionize how we interact with information.
Absolutely.
But I'm also realizing there's still a lot we don't know,
That's
a
right.
lot of challenges to overcome. What are some of the big open questions that researchers are grappling with right now?
Well, one of the biggest challenges is scalability.
Scalability.
Yeah, how do we make these long context LLMs work efficiently on even larger data sets,
Right.
like the entire internet?
Wow, the whole internet.
Another challenge is generalizability.
Generalizability.
How do we build LLMs that can handle a wide range of tasks and domains without needing to be retrained for each specific application?
That's a big question.
It is a big question.
And of course, there are always ethical considerations to keep in mind.
Right.
We need to make sure that these powerful tools are used responsibly and fairly.
Absolutely.
And speaking of ethical considerations,
Okay.
I'm curious about how this research might impact the way we think about AI safety and alignment.
Yeah, that's a great point.
If these LLMs are becoming more and more powerful, how do we ensure that they're aligned with our values and goals?
It's a really important question.
It is.
As we develop these increasingly sophisticated LLMs,
Right.
we need to be very mindful of the potential risks as well as the potential benefits.
So it's not just about building the most powerful LLMs.
Right.
It's about building the right LLMs.
Exactly.
The ones that will benefit humanity in the long run.
Absolutely.
Yeah.
And that requires collaboration between researchers, developers, policymakers, and the public.
It really does.
Yeah, we need to have open and transparent conversations about the implications of this technology
Okay.
and work together to ensure that it's used for good.
Well said.
Thank you.
This has been a truly fascinating deep dive into the world of long context LLMs.
It has.
We've explored the challenges of making them efficient and the exciting possibilities they hold for the future.
Right.
But before we wrap up, I want to bring it back to our listener.
Yeah.
We've talked a lot about the technical side of things.
Yeah.
But what does all this actually mean for you?
Right.
Why should you care about the KV cache and all these efficiency challenges?
Wait, why should you care?
Yeah, it's easy to get lost in all the technical stuff.
It is.
But we need to think about what it all means for us,
Right.
right? So if we zoom out and look at the big picture,
Okay.
what does all this research on long context LLMs actually mean
Yeah.
for our everyday lives?
This is where it gets really exciting.
Right.
Long context LLMs
Yeah.
have the potential to completely change the way we interact with information.
Wow.
Imagine searching the entire internet
Whoa.
in an instant,
Okay.
or getting personalized explanations of complex topics
Like tailored to me.
tailored to your exact level of understanding.
So it's like having a
100%.
super-powered research assistant at your fingertips,
Exactly.
available 24/7.
That's the goal.
Sign me up.
Right.
But how do we get from these research papers
Right.
to those real-world applications?
Well, the work being done on the KV cache
Uh-huh.
and these long context methods is laying the foundation
Okay.
for a future where these powerful AI tools are accessible to everyone.
To everyone.
To everyone.
That's amazing.
Think about how much easier it would be to learn a new skill,
Okay.
research a complex topic, or even just stay informed about current events.
Yeah.
If you had access to an LLM
Yeah.
that could understand and process vast amounts of information.
It's like we're on the cusp of a new era
It is.
of information access
Right.
and knowledge sharing.
Yeah.
It's not just about making things easier, though, right?
No.
These long context LLMs could also unlock
Right.
entirely new possibilities.
New ways of thinking and creating.
Okay, what do you mean?
Imagine writers collaborating with LLMs
Right.
to craft intricate stories.
Uh-huh.
Scientists using LLMs to analyze massive data sets
Okay.
and discover hidden patterns, or educators personalizing lessons
Whoa.
for each student based on their individual learning styles and needs.
That's a lot.
The possibilities are truly mind-boggling.
It's like we're giving everyone a superpower.
Right.
The ability to understand and harness information in ways that were never before possible. But with great power comes great responsibility.
As always.
We need to be mindful of the potential downsides. Of course, the ethical implications of putting such powerful tools
Right.
in the hands of so many people.
You're raising a crucial point.
Yeah.
As these LLMs become more capable and widespread,
Yeah.
we need to think carefully about how to mitigate potential risks.
Okay. Like what?
That includes things like ensuring fairness and preventing bias, protecting privacy and security, and being transparent about how these models work.
Okay.
and what their limitations are.
It's a lot to consider,
It is.
but it's also incredibly exciting to be part of this conversation,
Absolutely.
to be shaping the future of AI
Right.
and how it impacts our world.
It's a very exciting time.
So what can our listeners do
Okay.
to stay informed and engaged with these developments?
Well, the first step is simply to be aware of what's happening in this field.
Okay, how do we do that?
Read articles, listen to podcasts, follow researchers and developers on social media.
Right.
The more you understand about how these LLMs work
Okay.
and what their potential is, the better equipped you'll be to navigate the ethical and societal implications.
So it's like being an informed citizen
Exactly.
in the age of AI.
Yeah.
You're not just passively consuming the technology.
Right.
You're actively engaging with it and shaping its direction.
Exactly. And
Yeah.
don't be afraid to ask questions, share your thoughts, and participate in the conversation.
It's a conversation we should all be a part of.
This is a technology that will impact all of us. So it's crucial that we all have a voice in shaping its future.
Okay, so to wrap things up,
Okay.
what are some key takeaways for our listeners?
All right. So first,
Uh-huh.
long context, LLMs have the potential to revolutionize how we interact with information,
Okay.
opening up new possibilities for learning, creating, and problem solving. But we need to be mindful of the ethical considerations
Right.
and work together to ensure that these powerful tools are used responsibly and for the benefit of all.
This has been a truly fascinating deep dive
It is.
into the world of long context LLMs
Yeah,
and all the exciting and sometimes challenging implications they hold for the future.
absolutely.
Keep exploring, keep learning, and keep asking those tough questions.
Until next time,